All right, cholesterol. So here's the problem with cholesterol. There's really no good or bad cholesterol. This is cholesterol. Cholesterol is an organic molecule. So there's really no good or bad cholesterol. So cholesterol is this organic molecule. One of the things that I want you to recognize is that it has this steroid backbone, okay? That 4 fused ring. Steroids or cholesterol is a precursor for many steroid hormones that we have in our bodies. So cholesterol in and of itself isn't good or bad. As we'll see here, what it's transported with allows it to have good or bad sort of downstream effects in your body. But cholesterol by itself is not good or bad. It's an organic molecule that serves a lot of very important functions in our body. So just highlighting that, again, it's a very important biomolecule. Okay. About 30% of your lipid bilayer is actually cholesterol, and that's an important piece of it modulating the melting temperature or transition temperature of your lipid bilayer. So about 30% of your lipid bilayer is cholesterol, and that allows it to modulate your melting temperature. We talked about in class kind of that story of when you're making organic compounds in organic chemistry lab and you want to determine how pure it is, you take a melting temperature of it. The shorter the melting temperature transition, the more pure your sample is. The broader that melting temperature range, the more impurities you have in your sample. Well, the same is really true here with your lipid bilayer, but in your lipid bilayer, you want those impurities. You want that cholesterol sort of built in there because that helps broaden that transition temperature and allow you to have greater membrane fluidity over a larger temperature range. So again, lipid bilayer component, and there are tons of downstream uses of cholesterol. So lots of downstream uses of cholesterol. And importantly, we've mentioned a few times, statins inhibit cholesterol biosynthesis. Okay. And so statins are very good at kind of doing that. And so for many individuals, statins are a very important sort of component of their sort of health space and kind of maintaining good, healthy blood cholesterol levels. So this is a desired function. Is statins do a great job of sort of inhibiting cholesterol biosynthesis. So if you have elevated levels of blood cholesterol that are problematic, that can help, okay? But statins also inhibit the production of lots of downstream molecules that have important biological functions. And this is undesirable. You don't necessarily want to be inhibiting all of those different features, right? Some of our notes sort of walked through where we are sort of in that cholesterol biosynthesis pathway, remembering that cholesterol is ultimately synthesized from acetyl-CoA that's made into HMG-CoA as a precursor, and that's where statins kind of step in, is they prevent the conversion of HMG-CoA into cholesterol precursors. So it's actually pretty far upstream from the actual synthesis of cholesterol. And because of that, a lot of those cholesterol precursors go on to do lots of other important biochemical functions. So not only are we inhibiting the synthesis of cholesterol, we're inhibiting the synthesis of lots of these other molecules that have important downstream uses. So that's sort of the downside of statins, is we also inhibit those processes. Okay, so I'm going to zoom in down here just to talk about, and right, this little cartoon tries to indicate that LDL is the bad cholesterol, and then HDL is the good cholesterol. And that's sort of the language that unfortunately has permeated, and I hope I've highlighted that cholesterol is neither good nor bad. Cholesterol is a molecule, but what gives it good or bad connotations is the vehicle that it's transported in. So that's really the difference here between these, is they have different vehicles for transport. So different vehicles for transport. Okay. And so we're going to talk about what those vehicles are, kind of, and how they differ, in terms of different things. So let's just talk a little bit first about the names. LDL cholesterol is cholesterol that's packaged in a low density lipoprotein. So that's what LDL stands for. This is low density lipoprotein. And HDL is high density. And the density arises from the difference in the ratio between lipids and proteins, right? So lipids are less dense than proteins. Lipids are going to float on top of things. So low density lipoproteins are very lipid rich, where high density are more protein rich. So I've mentioned this idea of lipoproteins. Lipoproteins are really these vehicles that transport hydrophobic molecules like cholesterol, like triglycerides around your bloodstream. So that's the unique thing about lipids as a biological molecule. Unlike nucleic acids, most proteins, carbohydrates that tend to be fairly water soluble, lipids are not. So they need a transporter to carry them through the bloodstream. And so these transporters are lipoproteins. So again, LDL is low density lipoproteins because they're very lipid rich. HDL are high density lipoproteins because they're very protein rich. So at their core, though, they both contain different proteins on their surface. So the proteins that LDL contain are ApoB100, okay? And then ApoA1 are what we find on HDL cholesterol. And these really are the tickets, if you will, the directions for these lipoproteins for where they're supposed to go. So we're going to call these LDL particles containing ApoB100, these are inbound vehicles. And their directions are they take lipoproteins from the liver and they deliver them out to the peripheral tissues. And that's different from the outbound directions, that ApoA1 protein. That basically is directions that go from the tissues to the liver. And this is where these get sort of these connotations of good and bad, because when you're taking cholesterol and delivering it out to the tissues, that's sort of an outbound, and if you have too much cholesterol going outbound, that can be problematic. The inbound, okay, is really, and I've got this written actually incorrectly. So these are outbound. I have to fix this here. This is outbound. I may have said it correctly, or I don't remember if I said it incorrectly or not. These are inbound. Sorry about that. Correction there. So we've got inbound, okay, meaning that we are taking and bringing in sort of peripheral cholesterol and other lipids, and we are bringing them from the peripheral tissues to the liver. And this is a really important feature because for cholesterol, what happens is the only way to dispose of excess cholesterol is the liver needs to produce it into bile acids. Those bile acids need to be delivered into your GI tract, and you literally poop out excess cholesterol. It's the only route for disposing of excess cholesterol. So HDL is a particle that can bring that back to the liver for disposal. Again, LDL cholesterol, it's really an outbound molecule. It's taking cholesterol from the liver and delivering it out to peripheral tissues. And one thing I want to highlight here is that really the only problem, the only time that cholesterol is really problematic is when we have high concentrations with inflammation. So the only time that it's a problem is with, and I'm going to move this over because otherwise I'm going to run out of room here. The only time that it's a problem is when we have high concentrations with inflammation. And if you haven't sort of gotten this picture, this story yet from me, this kind of universal thread, inflammation is what is problematic in our body, okay? So high levels of LDL cholesterol are not necessarily bad if we don't have systemic inflammation in our body that kind of makes them problematic. Okay, so highlighting one other piece here, I want to talk about the fact that there's actually two main types of LDL cholesterol. Okay, two main types of LDL. We're going to call them A type and then B type. And this is highlighting the important piece that, you know what? Just knowing your LDL number is not necessarily the most important thing, because we need to know what subtype of LDL is it. Is it this A type, which we're going to call large and fluffy? I know that's very non-scientific, but these large and fluffy LDL particles are really important because they are involved in lots of cellular healing. Okay? These B type are what we call small dense. And these small dense particles tend to have a protein attached to their surface that we call LPA or LP little a. Okay? These are problematic because they are prone to oxidation. And that oxidation leads to inflammation. And again, highlighting this piece that things that are inflammatory are problematic, okay? And so what we really need to know, if we really want to know what's going on in our body, is we can't just get our, dollar store level of lipid panel where all we know is HDL, LDL, and total cholesterol. We need to kind of subdivide that LDL into what type of LDL particle is it, right? And we need to know, are there ways that we can determine the level of inflammation that we have in our body? Are we insulin resistant? Do we have high levels of C-reactive protein? All kinds of other things that can help us determine whether or not we are in this inflammatory state, which is ultimately going to have lots of problematic downstream aspects.